So in this example, we're going to do f equals ma, but in 2 dimensions. So far we've only done it in 1 dimension. So we've got this force, which is 3I plus 8j. So that means that there's a force of 3 newtons acting to the right and 8 newtons acting upwards. And what we want to do is we want to try and find out the acceleration of the particle, and we want to work it out in that vector form, pi plus qj. So we want the acceleration as a vector. So far what we would have done to solve this problem is we would have done f equals ma horizontally and f equals ma vertically, and we would have done them separately. So let's see what that would look like. So if we do f equals ma horizontally, then if we take to the right as our positive direction and up as our positive direction, if we just do it horizontally, we'd have 3 equals, now the mass of the object is 0.5 times by a. That's f equals ma horizontally. So we'd know that a equals 3 divided by 0.5, which is 6 meters per second squared. And let's call that a h, because that's actually our horizontal acceleration. And then if we wanted the vertical acceleration, we'd do f equals ma vertically. So let's do that. So if we do that, we're going to take up as our positive direction, because the particle is actually going to accelerate upwards. So we'd have 8 equals 0.5, and then the acceleration, I'm going to call it AV for acceleration vertically. So AV means acceleration vertically. And if we solve that, we'd find that the acceleration vertically is equal to 8 divided by 0.5, 16 meters per second squared. Okay? So that's doing it separately, and that's what we've done so far. Well, what we're going to learn in this example is actually we can do that in one step by using vector notation. So what we can do is we can actually use f equals ma, but we can say that f is going to be a vector and a is going to be a vector. So let's do that. So f is our vector 3, 8. That's the force that's acting on the particle. Our mass is 0.5, and our acceleration is what we're going to try and find. So let's write our acceleration. We're asked for it in the form p plus qj. So that's going to be p plus q. So pq, sorry. So that is our acceleration vector there. So if we multiply the vector pq by 0.5, we'd get that 3, 8 equals 0.5p and 0.5q as our vertical component. So we know that 3 equals 0.5p. So we'd get that p equals 6 like we got before. And 8 equals 0.5q. So we'd get that q equals 16. And here we've got our horizontal and vertical components, which we found before. The only difference is we've just done it using vector notation. So our acceleration vector, a, is equal to 6, 16. 6 horizontal and 16 vertically. So that's our acceleration. And we should write that as meters per second squared. In part B, we're asked to find the magnitude and the bearing of the acceleration of the particle. So this is our acceleration vector, and we just need to work out what's the magnitude and bearing of that vector, 6, 16. So let's draw a sketch of what that vector looks like. So that vector, if we just sketch it out, goes to the right by 6, and it goes up 16. So overall, our acceleration vector could be written as a vector that looks like that. That's our acceleration vector. So we want to work out what the magnitude of that acceleration vector is. And remember, that's our notation for magnitude of a vector. And we can just use Pythagoras. So it's the square root of 6 squared plus 16 squared. So the magnitude of our acceleration, if we work out what that is equal to 17 0.1 meters per second squared to 3 sig fig. Now we're also asked to find out what the bearing of the acceleration vector is. So bearing is the angle measured from north, or measured from the j direction. So we want to work out what's that angle theta. So let's work out what that angle alpha is, because we've already got a right angle triangle here. So tan alpha is equal to opposite over adjacent, 16 over 6. So alpha is equal to inverse tan of 16 over 6. So if we work out what that is, we get 69.44. So our bearing, theta, is going to be 90 minus 69.44, ... So we'll do 90 minus that. And we get our answer as 20.6 to 3 sig fig. Degrees to 3 sig fig.